You should have grabbed the notes from the back. If you didn't grab the foldable from the back, you need it. You do not need your calculator today, like we did yesterday.
I want one. No. Yes. No. That's not. Have it. No. There's only one left.
Do you need these from yesterday?
So yeah, I got one. It's not that long, but it's too long. Ow. This picture right here was the only one who did it. And then this one, which is about the and then this will kind of go in here.
So today's notes won't take too long if we stay on it and you guys get going and participate like we said. So every class today has had at least 10 to 15 minutes at the end of class to get things finished or to work on things. So yesterday at the very end, we talked about the A that is in the standard form.
That's not on
Okay. This is the standard form.
Hold up, what? Oh, never mind.
Would one of y'all close the door for me? Okay. This is the standard form that we briefly talked about at the end of our notes yesterday about the A in the standard form. And if it was positive, it told you that your parabola opened up. And if it was negative, it told you that your parabola opened down. That's the same A that's right here. In what form is this that we're talking about today? What form is this called, guys?
What?
It's on your paper there.
Vertex form?
This is the vertex form. Okay, so the vertex form gives you information. Specifically, it tells you what the vertex is, right? And it can help you know how the graph moves easier. So on these bullet points right here, these are just bullet points. Those are not zeros. Somebody earlier had asked that. So those are just bullet points there. What are these bars here? What do these mean? Those are absolute value bars, right? Okay. And the absolute value of a number means the distance that number is from zero. So when we talk about distance, we only talk about distance as a positive number, right? If we drive from here to Longview, we say, oh, it's 20 miles, right? And even though we're going south, we don't say it's negative 20 miles. We just say it's 20 miles. And then if we drive from Longview to here, we say that it's 20 miles, right? To Ore City or whatever, however we say that. We don't say it's a negative distance because distance isn't negative, okay? So that's what the absolute value bars are stating here, that we're just looking at the actual number that A is. We don't care about the symbol, whether it's positive or negative. We only care about the number value that A is. So when A is greater than 1, the graph is going to narrow. So that means it's going to get skinnier. If A is greater than 1, the graph is going to get skinnier. If A falls between 0 and 1, so that means on my number line, okay, if I have a number line, all of these numbers that fall between -1 and 1, those are these numbers that would fall into this category of A with the absolute value between 0 and 1, because all of these over here that are negative to -1, absolute value wise, is just positive. Okay? So any number that falls in that area widens the graph. So the graph would look like this, more like a smiley face, right? Okay? It would widen it. Here is where we deal with if it's a negative. The negative we think of as separate. So if you just look at the number itself, it tells you whether it gets narrower or it gets wider. The negative tells you that the graph reflects vertically. So it just flips upside down. So all of that information is told just from the A of your equation. Now, when we were dealing with linear equations and how that those functions transformed, when we dealt with the things inside the parentheses, remember how we said that it's the opposite. These always deal with the x-axis if it's inside the parentheses, and it's opposite of what it looks like. Okay? So inside the parentheses deals with the x-axis, and it's also the opposite. So right here, this looks like a negative h, but it's really a positive h when it talks about our vertex number. And it wouldn't move left, it wouldn't go negative, it would go positive, okay, if it's a negative sign there. Okay, so the horizontal shift, so it tells us left and right. Okay. So the h value tells us left how it moves left and right. The k that's out here, okay, so anything outside the parentheses deals with my y-axis. Okay? And it is just what it looks like. It's the same thing. So if it's a plus, it's a plus. If it's a minus, it's a minus. It tells me my vertical shift. So it tells me if the graph changes going up and down. So if you look at this equation down here that's in vertex form, what would you tell me that my vertex is based on the numbers that you see there? That would be one of the coordinates, but the vertex is a coordinate. Not -1. Why? Because it's the opposite, because it's inside the parentheses. So it's 1 and -3. Okay? So this green graph right here, oops. Okay. This green graph that I have drawn on my notes here is the parent function. Okay. It's the parent function. My parent function is written f of x equals x squared if I wanted to write my parent function in vertex form, or so it looks like it was in vertex form, I would have f of x equals x minus 0 squared plus 0. And so notice in my parent function that my vertex is right here at 0, 0. So when I draw my new graph, did I have anything in front of that parentheses right there for an a value? Do I have an a value right here in front of my parentheses? No. I have an invisible 1 there, right? So if you go back up here, oops. Goodness, sorry guys. Okay, if you go back up here and look at this, I'll go right back to that other, but right here, notice it's just less or greater than 1, and this one is just less than 1. Neither one of my things about a say or equal to, right? Because when you multiply by 1, does it change anything? No. Okay, so a 1 as my a value would not change anything in my parent function. Okay? It does not change anything. From the way that it is, the shape of it. Yes, ma'am.
Sorry to interrupt. Hey, I have Malaya Gale as a Chromebook that was dropped off.
Yes, ma'am.
Does she need it?
She will at the end of class. I'll send her when we get done with our notes.
That'll work. Thank you.
Okay, thank you. So so once you graph your vertex point right here, the pattern is going to still be the same. Up 1 and over 1. It doesn't matter which way you go over 1. Your other point gets reflected on the other side. And then from this point, it goes up 3 over 1. So I would do the same thing, up 3 over 1. So there would be my other coordinate. So that is how I got my new one, just by looking at my parent function and knowing that it wasn't going to change other than my vertex moving. So the transformation that happened is what I wrote down here. The transformation is talking about how it changed from the original to the parent, or from the parent function to the new one that was graphed. So my vertex went from 0, 0 to 1, negative 3. So it went right 1 unit, and it went down 3 units. That's the only change that occurred to it, is it just moved, it just slid down the graph some and over a little bit. So look at the inside examples there. All of these parent functions are already graphed for you, so you don't have any parent functions to graph on here. Okay, we're just going to graph the new functions. So the first thing we need to do is determine where our
Vertex.
new vertex is going to be.
2, -4.
Okay, 2, -4. Why is it a positive 2?
Because it's in the parentheses.
Because it's in the parentheses, so it changes signs. So my new vertex is going to be positive 2, -4, so it's going to be right here. Do I have an A value that's going to change whether it's wider or skinnier?
What?
No, because the 1, right, there's just that invisible 1. There's no number in front there to change it. So my pattern is still going to be the same. From the vertex, I'm going to go up 1 over 1 to get my new point. I'm going to reflect it to the other side as well. Remember, because we got that axis of symmetry that everything reflects over. Right? And then I went up 3 over 1 to get to the other point. So 1, 2, 3 over 1. And then it reflects over here. So there's my new graph. What change happened?
It just moved up. Moved down.
It moved down. Okay, so let's do our x change first. So from 0, 0 to 2, what happened? What direction is this? To here.
Wait. Yeah.
Well, what direction from 0?
It's an X.
From 0 to 2 would be right. Right? 2 units. That's how our x changed. And how did our y change? Our y went down 4 units. So in the one right underneath of that, what is my new vertex going to be?
2 and 2.
Right. Well, this one is 2, yes. But this one right here would be what's added out here. What's added afterwards?
0.
0. So it would actually be 2, 0. So my new coordinate is 2, 0. Right here. Or my new vertex is 2, 0. What does my A tell me?
That's 2. It says 2, but like.
So look back out the front. What did I say? If the A is bigger than 1, what's going to happen?
The graph widens? No, wait. Bigger than 1? The graph gets narrow.
It gets narrower. It gets skinnier. Okay? So you can call that a vertical stretch. Okay? It's going to get skinnier. Okay? It could also be a horizontal shrinking, right? However, because it's outside the parentheses, we usually refer to it as the vertical, right? Because vertical is your y. Okay? So it's a vertical stretch. It gets taller. Okay? It actually doubles. Okay? From here, it went from 0, 0 up 1 over 1. And now it would go up 2 over 1, just like it would with a slope. Okay, because it doubles. Now on your Get More Math stuff, I highly recommend that you actually graph the second one, so you can actually see the unit change, because even though some of them, it's a very easy, so like this, when it doubles, the pattern is obvious. It goes up to over 1. But when it's a fraction, like it is in this next one, it is not as easy to recognize. Okay, so just graph it, but if it just asks you if it's narrower or wider, then you're going to be able to tell just by the number. But if it actually wants you to do a units of how it gets skinnier or wider, I suggest that you graph it and look at it. Does that make sense? To verify. So what transformation happens?
Right 1 unit, down 1 unit?
Up 2 units.
It didn't go up any. It went
Right.
right
Right
2 units. It didn't move up or down any. It just moved over the vertex. That's what we're talking about when we're talking about moving. We're just talking about the vertex moving.
down 0.
Right? You don't have to write that it went down 0, because it doesn't matter, because it didn't move any. We just need to say now that it got narrower. And narrower, okay, and narrower could be also called vertical stretch. Okay, vertical stretch. If there are no parentheses and there's a number with no parentheses, because there's not parentheses listed, then it would, we figured this out last class, horizontal. I don't know how to spell horizontal shrink if there's no parentheses. So if it is in the parentheses, or if there is parentheses and it's asking you how it stretches or shrinks, okay, then the A is going to be talking about your Y, right? Because it's outside the parentheses. So it's vertical. Okay. If there's no parentheses on the problem in Get More Math, then it should be a horizontal shrink when there's no parentheses included. Okay. On this next one, what's the new vertex here?
The new vertex is 0, -4.
0, -4. Why is it 0?
Because there's no number in parentheses.
There's no number in the parentheses with the X. Correct. So in this case, it just drops down 4 units. Right? So it goes down 4 units. And it doesn't go left or right any. But what does this fraction do here?
It widens.
It makes it wider. So for this one, normally I would say, well, it goes up 1 over 2 like we would a normal slope, but it actually doesn't. Okay, it goes up 1 over 1.5. So these are the ones where I'm telling you that you need to look on, go ahead and put it on Desmos to clarify. Okay. So it goes up 1 over 1.5. So it is wider. Okay. So this is wider because that A is below 1, right? It's between 0 and 1, so it makes it wider. Okay. And the way that this could be worded is if there's parentheses and there's a fraction outside, then it'll be vertical shrink. Okay. If there's no parentheses, it would be horizontal stretch. Except I don't know how to spell stretch. Okay, horizontal stretch. Okay. So let me kind of zoom in on that a little bit for you guys so you can see those a little bit better. I misspelled horizontal on the one above there because I got too many Z's in it. Anyway, so so just pay attention and get more math. I was helping a few people with them, like I said, at the end of class, and we noticed that because it doesn't just ask narrower or wider on all of them like I thought it did. Some of them it wants you to specify whether it was vertical stretch or horizontal shrink or whatever. So that's the distinction. So just make sure that you are aware of that. And if you have people in your other classes that are not in this class, everybody who had me earlier today, other than fourth period, and only some of us talked about this, then you can share this information with them so that they will have it. I will probably make a note on Google Classroom to help clarify for them as well. Okay, so let's move over and do this next column, and let's see if we can get these done a little bit quicker now that we have a little bit more understanding of what we're doing here, right? Okay. So what's my new vertex here going to be?
Negative 3, 0.
Negative 3, 0. Okay. What does this negative right here out in front tell me? It's a negative 1.
That it widens. No, it narrows. No? Oh, graph reflects vertically.
It flips upside down. So like we talked about yesterday, right, is if the A is negative, then that means it opens downward. And if A is positive, it opens upward. So for this one, we would say it reflected. That's R. Reflected. Okay. And it went which direction?
Left.
Left 3 units. It didn't shrink or widen or get narrower or anything like that. So those are the 2 changes that happened for this one. If I look at this next one, what's my vertex going to be?
1,
1, 1. So it's going to be up here. And I've got a negative sign again, so what's going to happen?
It's gonna reflect.
It's going to reflect, and I have a 2, so it's also going to get skinnier. Okay. So it's reflected. Yes. It's reflected. How did it move?
Right one upward.
Right 1 unit, up 1 unit. And what else happened to it?
It got narrow.
It got narrower. Okay. Very last one.
Maybe this one.
Negative 1, positive 2. Yep. So it's up here. And I've got a negative sign there. So that means it flips upside down, but it's a -1, so it doesn't change whether it gets wider or skinnier. So it reflected. And then what?
Went right, left 1 unit and up 2 units.
Left 1 unit and up 2 units. And that's the end of our notes. That's the end of our unit about quadratic graphs and the vocabulary for them. Okay. So you do have 6 get more math problems to work on. There's 3 different kinds and you have to do them twice. Okay. So all of your 4-point get more maths are closed. So anything from this week, the 5-point whatever, and redoing that quiz can all be done. The quiz will close down before the beginning of class on Tuesday. So get that re-quiz done if you're going to do it to bring that grade up.
What is it called again? How do you get there?
So when you go to get more math, okay, is everybody done with these notes? Close that off. Okay. So in get more math, okay. So when you first open up, it should pop up like this. New exam bill. So you can go begin exam if you're ready for it. If you don't want to take it just yet and you work on your problems, then right here you go to this little menu right there on the side and exams and follow-ups, and it should say right here, follow-up, unit 7 follow-up. Yep. Okay. And how, based on however many problems you missed, will be how many questions you have in there.